Imagine you're locked inside this little tin can, like roughly the volume of maybe two minivans, and you are floating hundreds of thousands of miles away from Earth.
Yeah, just totally isolated out there.
Right. And you're running this scheduled test that intentionally drops the air pressure, the very air pressure keeping you alive, And suddenly over in the corner of the cabin, pieces of your vital communication equipment just start physically crumpling inward under this drain.
Like a crushed soda can. It's wild to even picture.
It really is. And, well, welcome to the reality of the Artemis II test flight. Today, we're bringing you on a deep dive into a deeply revealing set of sources. Specifically, we've got the direct communications transcript from NASA Johnson.
Which is such a goldmine.
Oh, absolutely. It captures the Artemis II Flight Day 8 highlights, so we are basically virtually riding along with the crew right inside the Orion spacecraft.
Yeah, and to put you right in the cabin with them, at the start of these highlights, Orion has officially been in space for exactly a week.
Wow, a full 7 days.
Yep, we're looking at a mission elapsed time of exactly 7 days and 6 minutes. They've successfully navigated around the moon, and right now they're hurtling back toward Earth.
And they have a very specific arrival time.
Right, they do, yeah. They're targeting a splashdown in the Pacific Ocean in exactly 2 days, 1 hour, and 25 minutes.
It is so incredibly easy to just get completely lost in all the technical jargon of spaceflight. I mean, it really feels like a completely different language half the time.
Oh, for sure. Acronyms on top of acronyms.
Exactly. But our mission today is a bit different. We want to uncover that profound intersection between this cutting-edge machinery and the deeply human, just visceral experience of leaving our planet.
Okay, let's unpack this, starting with the foundational question of this entire endeavor. Why are we even putting humans inside this machine at all?
Right. I mean, that is the ultimate debate of modern space exploration. Like, why not just send robots?
Yeah, robots don't complain, right? Exactly. A probe doesn't need oxygen, it doesn't need a pantry full of freeze-dried food, and it certainly doesn't have, emotional breakdowns when things go wrong. But the transcript gives us this brilliant, really nuanced perspective on this from NASA astronaut Andre Douglas.
Now, Andre Douglas is such a fascinating figure in this mission because he wears, like, so many different hats.
He really does.
Yeah, he's a backup crew member, and he works on the closeout crew, making sure the module is, perfectly sealed and the emergency escape systems are totally understood before launch.
Which is a huge responsibility on its own.
Totally. And he's also acting as Capcom, which means he is the voice communicating directly with the astronauts from Mission Control down in Houston.
Yeah, and he brings up this intense, really boots-on-the-ground physical preparation the crew did right here on Earth. I mean, they didn't just sit in digital simulators looking at screens all day.
Right, they actually went out into the field.
Exactly. Douglas details how the crew spent time studying geology out in Iceland, of all places.
Which, honestly, sounds like an amazing scenic work trip. Just going to Iceland to look at rocks.
It does sound nice. But there's a very rigid scientific rationale behind it. Iceland's volcanic, super barren landscapes are basically some of the closest geological matches to the lunar surface that we actually have access to on Earth.
Oh, that makes sense. So they're out there literally training the astronauts' eyes.
Yeah, rewiring their brains, really, to recognize geological formations, spot visual anomalies, and just read the deep history written in the stone. And Douglas uses this specific training to explain exactly why human eyes are fundamentally superior to satellites.
Right, because he brings up the Lunar Reconnaissance Orbiter.
Yep, the LRO.
And this is a satellite that's been slowly orbiting the moon, taking pictures for years now.
Yeah.
But Douglas points out the main limitation of the LRO. It really just gives us a string of 2D images plotted along a longitude axis.
Yeah, it's essentially taking flat strips of data that a piece of software has to stitch together later.
Right.
I mean, it's a highly sophisticated scanner, but at the end of the day, it's still just scanning. It lacks intuition, it lacks depth perception.
And that's where the humans come in.
Exactly. When you have human beings doing a flyby, they can use their own minds to make rapid, real-time decisions. They figure out what angles are best based on the shadows, they know exactly when to zoom in on a weird-looking crater, and they know when to pull back for wider context.
They're essentially combining their dynamic human perspective with the LRO's static data to create a truly complete three-dimensional understanding of the lunar surface.
That's spot on.
Let me put it this way, because thinking about it like this really made it click for me. Think about looking at a mountain range on Google Earth. Yeah. You are staring at this flat, top-down satellite view.
Right, you can see the shapes, but it's flat.
Exactly. You can see where the peaks are, you can measure the distances between them, maybe map out a trail. But compare that flat screen to actually standing on the peak of that
Oh,
mountain.
it's totally different.
Right. From the peak, you can visually calculate the plunging depth of the valleys. You can physically feel the temperature drop. You see a storm front rolling in over the ridge, and you instantly understand the scale, the context, and the danger in a way a stitched-together satellite map could literally never convey.
What's fascinating here is how Andre Douglas extrapolates that exact concept to our future missions to Mars and even to establishing a permanent lunar base.
Oh, really? How so?
Well, he argues that this human 3D perspective is absolutely crucial for understanding dynamic, changing systems. He uses the International Space Station as his primary example.
Okay, at the ISS.
Yeah. When astronauts on the ISS look down at Earth, they don't just see a static map. They see massive cloud formations building in real time. They see hurricanes moving across the oceans.
And they fly over those same hurricanes every 90 minutes.
Right, because they're orbiting so incredibly fast, they see the storm evolving from completely different angles over a really short period of time.
Wow, yeah.
They're observing atmospheric phenomena that a flat, two-dimensional timestamp simply cannot capture. They're getting both a spatial understanding, like how big it is, and a temporal understanding, how it behaves over time.
So Douglas is saying that when we take that human ability to synthesize spatial and temporal data and apply it to an environment like Mars, it's going to unlock this ultimate view of the solar system that robotic rovers alone just cannot provide.
Exactly. Humans bring context that robots just don't have.
But, to get that beautiful, profound three-dimensional view of the cosmos, you first have to actually survive living inside a highly technical, incredibly cramped tin can.
Yeah, the not-so-glamorous part.
Right. We have to pivot and talk about the gritty reality of day-to-day operations aboard Orion on Flight Day 8. Because like you said, it is definitely not glamorous. The physical toll of being in a microgravity environment requires constant, exhausting mitigation.
It really does. Muscle atrophy and bone density loss happen super rapidly in space. Commander Reed Wiseman calls down to Houston at one point to proudly confirm that he has just finished his final exercise session of the mission.
Good for him. That sounds tough.
Oh, yeah. And he specifically praises a piece of equipment called the flywheel device because, in microgravity, you can't just lift weights. A 50-pound dumbbell literally weighs nothing.
Right, you just be throwing it around the cabin.
Exactly. So the flywheel uses rotational inertia to provide serious physical resistance. It gets their heart rates up and maintains their muscle mass without taking up the enormous footprint of, say, a traditional treadmill.
And right alongside that physical maintenance is the daily logistical reality of 4 full-grown adults living in the volume of 2 minivans. Which brings up a moment of the transcript that is just so deeply human.
I know exactly what you're going to say.
NASA astronaut Victor Glover calls down to Houston to do an audio check on their new Peltor noise-canceling headsets. They are testing the Bluetooth feature to talk to each other wirelessly inside the cabin.
Yeah, wireless comms in space.
Right. And Glover, in this completely deadpan delivery, reports that the headsets work incredibly well. Yeah. So well, in fact, that they can clearly hear each other even when one crew member is actively using the toilet.
It's so funny. It perfectly highlights the absolute lack of privacy up there.
Totally.
I mean, you're flight testing multi-billion-dollar aerospace communication systems, and the primary metric for success in that specific moment is whether you can chat clearly while your coworker is using the bathroom 3 feet away from you.
Reading that made me laugh so hard, but it also leads me to something that genuinely confused me in the transcript.
Yeah.
I want to push back a little on this idea of seamless cutting-edge tech.
Okay, what stood out to you?
Well, I'm reading through this log, marveling at the Bluetooth toilet headsets, and then suddenly I see Capcom Stan Love calling the crew because they've completely lost their optical communications signal.
Yeah, the laser link.
Right, they lost their laser link to Earth. A solar panel is blocking it. I mean, with all of this advanced futuristic technology, why are they dealing with something as seemingly basic as a solar panel blocking their space Wi-Fi? It just feels surprisingly fragile to me.
I get that. It definitely feels fragile on the surface, but we really have to look at the sheer complexity of the orbital geometry happening here.
Okay, walk me through that.
The Orion spacecraft isn't just flying in a straight line like a car on a highway. It is a super delicate balancing act of competing needs. It needs power, right? So it has to constantly rotate to keep its solar panels pointed directly at the sun.
Right.
But it also generates intense heat, so it has to keep its radiators pointed away from the sun out into deep space.
Okay, so power and cooling are pulling it in two different directions.
Exactly. And then on top of that, it needs to talk to Houston, so it has to keep its antennas pointed at Earth.
Hmm.
Sometimes those three geometric requirements conflict, and a massive solar array just sweeps right in front of the communication laser. Oh, wow. So it's literally just the physical positioning that gets in the way. So how do you fix a blocked signal when you're hundreds of thousands of miles away?
Well, it requires a highly specific and honestly deliberate maneuver. Stan Love walks Commander Wiseman through it. They basically have to execute a 25-degree roll of the entire spacecraft using their thrusters.
Oh, wow.
Yeah, and it takes about 1 solid minute to complete the rotation. The goal is to shift the vehicle to a new attitude where the optical comms finally have a clear, unblocked line of sight back to Earth.
It's kind of like trying to get cell service in a remote area by holding your phone up in the air. But imagine the phone weighs 50,000 pounds. You have to rotate the entire thing using explosive thrusters, and if you tilt it 1 degree too far, your phone permanently shuts off.
That is a terrifyingly accurate analogy.
Right. And Stanlove explicitly warns Commander Wiseman that this is a risky move. I mean, the stakes seem bizarrely high for just adjusting an antenna. They are incredibly high. Love explains that during this specific 25-degree roll, they will only have one single phased array antenna pointed in the correct direction.
A phased array antenna.
Yeah. A phased array isn't a traditional satellite dish that physically turns. It's a flat panel that steers the radio beam electronically. And if that single phased array fails during the 1-minute maneuver, they cannot just do what NASA calls a string swap.
A string swap being their standard backup procedure.
Yes. Think of a string swap like having a backup generator kick in when your house loses power.
Okay.
But Stan Love is warning them that during this specific rotational angle, they don't have a backup generator plugged in. The geometry just won't allow it. A string swap will not recover the signal.
Oh, geez.
If the primary goes down, the whole house goes dark. They would suffer a complete loss of communication with Houston.
So if that happens, the crew is instructed that they will have to manually maneuver the spacecraft back to an attitude known as bias tail sun.
Exactly. Which means using their manual controls to orient the tail end of the spacecraft directly toward the sun. That specific orientation would finally allow a different set of antennas to get a clear line of sight to Earth so they could reestablish contact.
But they'd be doing that entirely on their own.
Right. It would be a manual, completely blind maneuver executed in total radio silence.
Just to send down video feeds and data, they are threading a needle in a vacuum, knowing that one failed component during a 1-minute roll could completely sever their connection to humanity.
It is so intense.
It really is. And it serves as a stark reminder that Artemis II is not a joyride. It is not just a sightseeing tour of the moon. Fundamentally, this is a dangerous test flight.
If we connect this to the bigger picture, every single hurdle they face, every manual maneuver they execute, every alarm that goes off is the entire point of the mission. They're out there actively trying to find the structural and technical limits of the Orion spacecraft so that future missions, ones which will be much longer, landing on the surface and eventually heading to Mars, are actually safe.
And we see them actively pushing those limits on day 8 with the cabin repressurization test. This part of the transcript is fascinating because they are intentionally messing with the air pressure inside the ship while they are literally living in it.
Right. This was a major demonstration flight test objective for them. They purposefully held the cabin pressure at a target of 10.2 psi for an extended period.
And for context, normal atmospheric pressure at sea level on Earth is about 14.7 psi.
Exactly. Dropping it to 10.2 psi is roughly the equivalent of living at the summit of a very high mountain.
Wow.
They're running the cabin at this significantly lower pressure to see how the environmental control systems react under stress.
Then they start bringing the pressure back up. The transcript notes it leveled out at 13.27 psi, and then finally they flooded the cabin with air to complete the repressurization back to a normal 14.7 psi, which they maintained for the rest of the journey home.
And testing these pressure limits is absolutely non-negotiable for human survival on future missions.
Definitely.
If we're going to build airlocks for lunar landers or construct massive habitats on the surface of Mars, we have to know exactly how spacecraft structures handle vast, sudden shifts in pressurization. We need to know what bends, and more importantly, we really need to know what breaks.
And something almost did break during this test.
Oh, yeah.
This is where Commander Wiseman's real-time feedback is so crucial. After the cabin is fully repressurized, he calls down to Houston with a very specific note with the engineers designing future Artemis missions. He says that during that large, sudden repressurization, certain items in the cabin, specifically something he refers to as the CCUs, collapsed significantly.
Yeah, the CCUs are the crew communication units. They're essentially these sealed electronics boxes that process the audio for their headsets. And they were physically crushed inward by the sudden increase in air pressure.
I want to break down the physics of that for a second because it's just wild to picture. Think about taking an empty plastic water bottle onto a commercial flight.
Wow, that's a great example.
Yeah, if you put the cap on and seal it at cruising altitude where the cabin pressure is slightly lower and then the plane lands at sea level, the heavier, denser outside air literally crushes the plastic bottle inward.
Yep, happens all the time.
That is exactly what happened to their communication gear. The air inside the unvented CCU boxes was trapped at that thin 10.2 psi. When they flooded the cabin with dense air to bring the overall room up to 14.7 psi, that heavier external pressure literally crushed the metal boxes inward.
It's crazy. Wiseman reports that there was no permanent damage to the electronics, luckily, but he strongly advises Houston that on future flights, they really need to manually vent these items along the way as the pressure comes back up so the air can equalize.
See, this to me is the ultimate argument for having human test pilots instead of just running computer simulations.
Oh, 100%.
A computer telemetry readout can tell mission control that the pressure increased perfectly from 10.2 to 14.7. But only a human being is going to notice a piece of vital communication equipment physically crumpling in the corner of the cabin and have the insight to say, hey, we need to add a manual venting procedure to the rulebook.
It is that real-time analog troubleshooting that ensures the safety of the crews that will follow in their footsteps. They are literally writing the survival manual as they fly.
And it is precisely because they are forced to endure that kind of gritty technical stress, sweating through pressure tests and risking communications blackouts, that the emotional release of this mission is so intense.
Oh, definitely. The contrast is huge.
Surviving the cold machinery is what allows for the profoundly unscripted human moments. Because once the machines are stable, the human reality sets in. We see this so vividly during their press conference on day 8 with Marcion Dunn of the Associated Press.
Yeah, Dunn asks Commander Reed Wiseman to describe his emotions regarding a very specific, deeply personal request the crew had made to mission control.
Yeah.
The crew had actually asked for official permission to name a newly observed lunar crater after Wiseman's late wife, Carol.
Reading this part of the transcript, you can just feel the shift in the cabin. Wiseman's response is incredibly raw. He reveals that naming the crater wasn't actually his idea at all.
Right, it was his crewmates.
Exactly. His 3 crewmates, Christina Koch, Victor Glover, and Jeremy Hansen, approached him while they were in quarantine at Kennedy Space Center before the launch.
And think about the psychological reality of that quarantine. You have 4 people locked away from the rest of the world facing down the barrel of a rocket launch.
That kind of intense isolation breeds a unique, really profound empathy.
It really does. They had talked among themselves and decided they wanted to do this to honor his loss.
Wiseman calls the gesture a total treasure, but he openly admits to Marcion that he was just too overwhelmed by the weight of it to actually make the call to Houston himself.
Yeah, he tells her, I can't give the speech, I can't give the talk.
So Jeremy Hansen steps up and says he'll handle the communication.
Yeah.
And Wiseman describes the scene inside the cabin as Hansen is making the call down to Earth. And it is so incredibly vivid.
It gave me chills reading it.
Right. He says that when Jeremy officially spelled out Carol's name for the historical record, Carroll, that was the moment the emotional dam just broke for everyone.
Wiseman says he was completely overwhelmed with emotion. He looks over, and Christina Koch is actively crying. He looks at the Jeremy Hansen, who's still trying to talk to mission control, and he sees that Jeremy's hand, which is resting on a metal handrail, is visibly trembling.
Wow.
So Wiseman reaches out and puts his own hand over Jeremy's trembling hand. He admits they all pretty much broke down right there in the middle of the cabin.
It is such an extraordinary image. 4 highly trained astronauts in the middle of a high-stakes, dangerous test flight, hundreds of thousands of miles from Earth, brought to tears by an act of deep shared empathy. So what does this all mean?
Well, when Wiseman is asked by the press how this journey has changed his perspective, his answer is surprisingly grounded.
Oh yeah. He says looking out at the endless, terrifying void of space didn't actually change his perspective. It just absolutely reaffirmed what he already believed.
Exactly. He sees how fragile our planet is against that black backdrop.
And his ultimate takeaway is that human purpose is simply about finding joy, lifting each other up, and creating solutions together instead of destroying.
And that shared vulnerability is the exact thing that forges a successful crew. Wiseman actually calls that emotional breakdown over the crater a caging moment.
A caging moment.
Yeah, it forged them, it bonded them, and it completely focused them for the intense, dangerous days of reentry that lay ahead. They weren't just four highly skilled coworkers anymore, they were an unbreakable unit.
Here's where it gets really interesting. Just when you think the emotional weight of this transcript has peaked, the crew delivers one final surprise before they sign off from their public affairs event. The flight, they tell Houston they have one more thing to show the world, a special item they unpacked that morning. Victor Glover floats it up to the camera. It is a flag, but not just any flag. It is the Apollo 18 flag.
The historical lineage of this specific piece of fabric is staggering.
It really is.
As they state in the transcript, this flag was originally meant to be planted on the moon during the Apollo 18 mission, which was, of course, ultimately canceled, but the space agency kept it safe. It was eventually flown on Skylab, it flew on the space shuttle, it resided for a time on the International Space Station.
And now, the Artemis II crew has carried that exact same flag further around the far side of the moon than any human being has ever gone, and they are bringing it safely back home to Houston.
They talk about it in the transcript like it's a sacred relic.
Yeah, they do.
They say they're honored just to be in its presence and that they're literally carrying the torch from the Apollo generation into the future.
It is the perfect synthesis of everything we've unpacked today. It's just a simple piece of analog fabric representing decades of relentless engineering and dangerous technical milestones, carrying the invisible weight of human history and ambition around the dark side of the moon.
That's beautifully said.
As we wrap up this deep dive, I want to bring all of this massive cosmic scale back down to Earth. Literally. We started by looking at the orbital mechanics, the crushing physics of the pressure tests, and the sheer terror of communication failures.
The technical side.
Right. But the beating heart of this mission transcript isn't really about the machine. It is about the people inside it. You, listening to this right now, you're probably never going to have to execute a 25-degree spacecraft roll just to fix your Wi-Fi.
Let's hope not.
And you're probably never going to have to worry about a sudden shift in atmospheric pressure crushing the electronics in your living room. But Commander Wiseman's perspective, that in a vast, cold void, our only real job is to protect our fragile home and find joy in lifting each other up, that applies directly to you. It applies to every single one of us navigating the gritty reality of life right here on the ground.
You know, this raises an important question, though.
What's that?
Well, as we successfully test these systems, as we push through these brutal barriers to establish a permanent human presence on the moon and eventually Mars, what happens to the significance of these deeply human gestures? If we get to a point where we have regular daily routine flights to the lunar surface, will an intimate act like naming a crater for a lost loved one retain its profound, lonely majesty? Or, as space becomes familiar and routine, will the cosmos simply become a sprawling, ordinary extension of our earthly neighborhoods?
Wow. It is a beautiful and honestly slightly terrifying thought to leave on. Thank you so much for joining us on this journey through the Artemis II transcript. Keep looking up, and we'll catch you on the next deep dive.
Thanks for listening.
And just remember, no matter how advanced the machinery gets, it is the messy, emotional human heart that actually makes the journey worth taking.